Hi there, everyone. So I'm so glad you could come here and join me. Um, it is an interesting year to be doing it this way. I'm sure you're getting that intro from absolutely every prof that you're talking to, and I'm sure everyone's using different formats and different methods. Obviously, clearly for this class, which is ARC281 or Structures class for the undergraduate architecture program, we're going to be doing our videos on YouTube, which if you're watching this, you've already seen it there. Just to give you a little bit of information about myself, my name's Shannon Helchie. I'm a professional engineer. I've been practicing for close to 20 years. I started out working for a really funky company called Blackwell Engineering. I worked there for 11 years, and then I did consulting work with them. I still do consulting work with them periodically. After that, I decided to try something else for a little while. I worked for Cast Connects, which is a steel casting company that do some of the coolest stuff you've ever seen. But I really missed just doing engineering. I was doing a lot of technical sales. I was still doing engineering with them, but I really missed kind of putting pen to paper and doing the work myself. So I started my own company called Fat Lab. I know it looks like it's spelled weird, but all of the cool spellings of fat were taken by the music industry, mostly because I had a Fat Lab at the time. I do high-end installations or structure that doesn't really have a normal place in the building code. But I still do large buildings when I consult with Blackwell, for example. Shortly after I started my company, U of T approached me and asked me if I wanted to teach the graduate courses for the structures program. I, of course, said yes, and I've loved doing it. And then this is the third year, I believe, that we have, or the fourth year, that we have introduced this program, or this class, to the undergraduate classes. So there will be math in this. So get your calculators out, dust them off. I don't know how long it's been since you've used them. The math I'm going to give a little rundown again about for you. So let me just get my mouse up here. I'm doing a split screen capture, and 5 minutes ago was when I downloaded the software, so bear with me for a few little bugs, I'm sure. These are just a few projects that I've worked on in the past. Some of these were with Blackwell, some of them were on my own. We don't have a lot of time, and it's only 2 hours per class. The graduate classes get 3 hours, and they get 24 of them. You get 12 2-hour courses, they get 24 3-hour courses. And we're cramming, you guys are doing 80% of their work, so good for you guys. You can see some kind of really cool stuff that I've had the opportunity to work on throughout my career. This one here, I was going to say, as you walk around campus, but that's probably not happening as much as it normally would. But this is the Varsity Centre for High Performance Sports. That's right on the U of T campus. Some of you have probably even been in it at some point, or might go in it throughout the next few years. This was an absolutely incredible project to work on, and I was so fortunate to get the opportunity to work on it. But it's essentially a 54-meter bridge. As much as it looks like it comes down and touches the ground right here, this is just where lateral loads come out. The only place this building touches down is here and over here. So what are the requirements for you guys for this course before we jump right in? And I'm probably going to do this in two videos, just so that you guys can take a little break. And the best thing about this is you have to go pee, you pause the video, you go to the washroom, come back. One of the things that's gonna actually be quite hard to do is normally I do calculations up on the screen using a pen on my tablet. This software, I might figure out how to work that a little bit better later on in the term, but right now I can't do that. This lecture doesn't really have any math that we need to do this with, but what I would probably do is say, when we come to a math question, say, this would be a good time to go look at the alternate video. And I would do a specific video just of the camera looking down at my hand, writing out the math equations, so that you guys can, I find it really handy to actually see what someone's writing to kind of really absorb it. So I really want to give you guys that opportunity, not just show answers up on the board. So these videos will show the answers. the other video, not this week, but the other video will show the calculations worked out. So your marks are broken into 3 parts: assignments, quizzes, and exams. The assignments will be found on Quercus the day of the class. It will be up for 1 week. The day after that, all of the answers will be posted. Sometimes those answers will actually have some notes to go with it or an explanation to kind of expand on it. There's no time limit on the assignments, but make sure you submit it once it's completed. So you can kind of work on it. I think you can even save your answers, walk away from it, come back, but don't hit submit until you're absolutely done it. Like I said, the answers are available the day after the due date. Because we have this weird format and we don't have tutorials the way we normally would, and I am teaching 3 classes this term, trying to fit in dedicated time for just one particular class is difficult to just be there and answer all the questions. So what we're going to do, because we have all these wonderful TAs, the TAs are going to be your first resource. So in the program, it should, or in your timetable, it should show what lecture group you're in, and you will have a TA assigned to you. I don't have that TA information yet, but hopefully it'll be up by the time you guys kind of start watching these videos, or next week sometime. You will email your TA. Their email addresses will be in the course outline, which will be posted to Quercus in the downloads file. You will email your TA your questions. The TAs will kind of take those questions and compile a list, because if you have the question, probably 10 other people have the question as well. And they'll kind of compile it down to a list of 10 to 15 questions for me. If it's easy, the TAs will try to answer it themselves, no problem. And then each week what I'll do is, sometimes it might be easy enough to answer all the questions in the announcement section or in an extra page on Quercus. If not, I'll do another video recording kind of addressing each of the questions, just so that if you have the question, someone else might have it and they might not have had the courage to ask it. So we'll whittle down the questions that way, but also make sure everybody gets the benefit of all the information. All the assignments have equal weight. It's going to show in Quercus that they have different values. Don't worry about that. You'll at least see what your mark is for each assignment. So if you got 19 out of 19 on the first assignment and 24 out of 24 on the second assignment, they'll all be worth the same amount at the end of the term. So don't worry about that, and the accumulated mark of them will be worth 30%. I take the Quercus marks and download them into an Excel file and then change them to a ratio so that everybody gets, so you always get all the same marks, or you get all the same percentage per assignment. If you cannot meet the due date for an assignment, you have to let us know. I understand people can be sick. I understand things can happen, and that is totally understandable. But you do have to let us know. Coming to us 3 weeks afterwards and saying I was sick isn't good enough. You have to let us know, and we will do everything we can to make the arrangements so that you can deal with that. All right, quizzes. Quizzes are going to be almost identical to the assignments, except they're only 15 minutes. You only have 15 minutes to complete them. So do not start that quiz until you're ready to finish the quiz. If you start it and don't finish it, it'll end on you. So same thing, they'll be available for a week, but you don't have unlimited time to do it. Don't start it until you're ready to finish it. The day after the quizzes are due, which is a week after, or Tuesdays at midnight, the answers will be available on Quercus. So you'll have all of the answers available to you. Similar to the assignments, sometimes there might be a quick little blurb with it, kind of just pointing out interesting facts. For both of these, you should have a calculator handy. The quizzes will definitely have math involved in them. But like I said, they're 15 minutes. I'm not there to make you cry. I want to make it so that you're learning something. I'm trying to tag on the key points we're going to learn through each lecture. And the calculator is just to kind of do some quick math to kind of test out the concepts. They're also your practice questions for the exam, which is the next slide. Again, submit all your questions to the TA and they'll compile a list for me. The exam. So it's worth 40% of your term. You're going to have lots of practice questions having done the quizzes throughout the term. Similar to the quizzes, not everybody gets the same question. The questions will be similar, but you might have different numbers in them. You might have, there might be a pool of questions that are all very similar or the same difficulty level, and I might make 5 of them in a question pool, and it auto distributes them amongst the class. So you won't always you won't have the same questions as the people next to you, or not next to you, your friends who are in their house. They will have a variety of types of questions, multiple choice, fill in the blank. There will be formulas. I will tell you how many significant digits or decimal places to fill in your answer to. I try to be very explicit, and I will tell you the units that you need as well. Obviously, it's open book, similar to the exam or to the quizzes. I will give you a PDF that I upload to Quercus that is kind of just a compilation or a quick resource so that you're not trying to look through, 100 different things during the exam, killing time. That will contain probably 95% of the charts and tables and things that you needed to do the exam. Lists, you'll have to know that from the lectures, or maybe make your own little sheet of things that you think are relevant, or a shorthand sheet of the things that you think will be relevant for the exam. I give you that appendix well in advance of the exam so that you have a chance to look at it and see what it looks like. I always get the question, you only gave us 3 pages out of the climatic data. We'll talk about what that is later. And it was 60 pages long. Well, that's because all of the questions are only going to use those 3 pages. I'm not going to reference something from the other 57 pages on you. That would be just cruel. It's obviously open book. Has to be honor in this. I can't stop you from using the internet to look things up. I made that mistake in the end of the term last year in March for my exam for my grad class. The question that had always been the absolute hardest question in the entire exam, always, that had a success rate of 40%, that was the lowest. That's not normal. Most of them are really high. Had a 100% success rate. So clearly there was communication amongst the students, which made me a little bit sad. But the takeaway I took is that they learned how to do it because they had to actually go through some steps to get there. So at least they learned something. I have to try to make it, the administration requires us to make it as cheat unfriendly as possible. So I will do everything I can. But the thing I care about is that you learn something. So please give it your best effort. The classes are going to have this video that I'm going to post to Quercus that also has the slides shown. You can follow along on the PowerPoint presentation as well, which is also uploaded to Quercus. The first slide, I try to outline the talking points that we're going to discuss in the class, so you're kind of prepared and you know what's coming. I also take a slide at the end that summarizes the things that I think are really important. And I usually break it into 2 categories. There's the things I just think are really important that aren't really testable, that you should just know forever, especially as you go into a career in architecture. The second list is, yeah, I'm going to test you on that. I have to test you on it. It's exactly the mandate of the course to test you on that. I'm going to try to post these lectures every Wednesday. Often they'll be posted ahead of time, but if it's Tuesday and it's not posted there, don't freak out. It's coming. Like I said, the TAs, if you have questions, start with them. They'll try to compile the list. If you do have to contact me, please list what course you're talking to me about. I don't want to get emails of what time is the exam? Do we have to mark, are you going to mark these? If the answer is in the syllabus, I'll just answer, check the syllabus. Those are really good questions to annoy a prof. You've probably all seen the memes of how best to piss off a prof, and it's to ask a question where the answer's in the syllabus or the course outline. There are obviously a lot of you and only one of me, which is why we have the TAs. I'm also teaching 2 other classes this term, which is why it's important to let me know what course you're asking the question about, because they're all the structures course. So it's pretty much the entire structures curriculum at Daniels. So they all have very similar information in them, but they are different. So if you don't tell me what course it is, I can't necessarily derive it based on the question alone. The extra kind of wrench thrown in there is that When I agreed to do all this, my 4-year-old was going to be starting school and my 2-year-old was going to be in daycare. That is not the case. We are going to be having them at home and homeschooling them. We have somebody helping out several days a week, but not all of the days of the week, so I'm not 100% available. If you also see a screaming kid run through the video, I apologize in advance. Normally they're very cute and adorable, but sometimes they do have meltdowns. Remember that at any given moment, I am pretty damn close to my breaking point. I'll try to never take it out on you, but I am teaching a lot of things at the moment and juggling a lot of balls. But that said, you guys are a top priority and I want to do whatever I can for you. So what's my job? My job is to meet the requirements set out in the lesson plan. I think that's pretty obvious. To meet the needs of the majority of the class. That sounds like a really jerk statement to make there, but it's not, and it's really important. There's a variety of skill levels coming into this course. Some people are going to find the math super easy, and I get every year 20 comments that the class wasn't hard enough. I also get 20 comments saying that the class was too ridiculously hard and it shouldn't be in the curriculum this way. Obviously, those are the outliers. It's everyone else in the middle that the course is geared to. If you are in the advanced set, make it harder. You can take it farther. You can look things up. You can do what you can. If you are in the other end of the spectrum, the TAs and I are going to do what we can for you. But if you think you need it, try to find a TA. Reach out to other a tutor. Reach out to other students in the class. Maybe pair up with those people that are in the high end of the spectrum and find this really easy. The last one is to be reasonably available, but I have to be reasonably available to absolutely everyone, which means that your questions have to be thoughtful. They have to be things that you couldn't have figured out just by looking through the course information or by asking your TA, just because there are so many people that are going to be asking questions. Your job, obviously, watch all the posted videos, review all the PowerPoint presentations. You should definitely review all the examples. I'm going to post downloaded material to a download module on Quercus, so you should be downloading all of those things. Definitely submit your questions to TAs. You should complete all the assignments. Please, they're easy marks. If you do your assignments and quizzes, it is really hard to fail someone. That is 60% right there. If you do everything, you've got all the time in the world. You've got a week to do the assignments. The quizzes, I recommend doing the quizzes after you do the assignment because sometimes the questions might be very similar. And just study for the exam. I don't want to fail anyone. It is a butt-ton of paperwork for me. I have to email things, I have to validate it, and then you're gonna complain, and I have to look stuff up, and I have to convince the administration. Don't make me do it. I don't wanna do it. So let's just all pass this course, please. You should take some notes, but like I said, the slides are available. Some of this one's maybe a bit old, because it was when we were doing it live in a classroom. I recommend making your own little kind of booklet of the things that are probably going to be on the quiz. Lists. I love having list questions in exams and quizzes. Equations. Write down equations so that you just have a list of equations and what they are. Very handy, right in a small little booklet for yourself. Listen to my cues. I will often say, really good exam question here. And those usually almost always end up in the exam. What really makes me sad is when I say, hey, this is the perfect exam question, and 20% of the people don't get the question right. I'll even often write it in the slides, which means there's no excuse for not knowing that that was going to be an exam question and knowing what the answer was. So one of the big questions I always get is, why is there no textbook? Trust me, I would absolutely love for there to be a textbook for the courses that I'm teaching. And I guess technically there is, but it is all little bits of a variety of books. So the Hibbler's Statics book, which we're going to cover chunks of, not that book, but statics. We're going to cover statics as a thought process. Structural analysis, which is forces and free body diagrams and basic kind of how things don't move. the Building Code of Canada plus its commentaries, which is what we design everything to in Canada for structural engineering. And then each province might also have its own building code, and Ontario has the Ontario Building Code. And then we actually have to talk about all the different materials. We don't have time to talk about all the construction materials, but we're going to talk about the top 3, which is wood, steel, and concrete. As you can see, the total of all of those kind of prices adds up to something very pricey. And then to top it off, all of the ones that have examples are American. So they don't apply in Canada. The methods might be similar, but we're going to talk about load combinations and load nomenclature and how we do limit states design. And they're almost identical, but not exactly the same. So if I gave you the American examples, we'd have to put a disclaimer on absolutely everything. So it's really tough to recommend a textbook without breaking your bank. That said, feel free to take a look at any of those things, go to a library, check them out. If you want, spend the money, buy them all. I don't care, but it is definitely not required. I will, especially from the codes and manuals for the materials, provide the pages that you need that are relevant from that. I am sort of working on at least a portion of a textbook for you. The wood industry, or the people here that make this wood design manual, are also producing a design guide for wood construction for architects, covering both stick frame and mass timber. And me and my husband, who owns Blackwell Engineering, are writing 2/3 of the book. And those portions are, especially the portion I'm writing and the third I'm writing, are a large portion of what we're going to be doing in this course. So once that's comes out, depending on how they publish it, I will have a very strong resource to recommend to people. But I'm also writing that this term to add it on to the plate. Plus I have my own company, obviously. Online resources. If you find anything confusing, don't hesitate to ask the TA questions. This is not trying to stop you from asking questions, but the internet is a valuable resource. If there is a term you don't understand, Google it. You are going to find 100 pages that talk about it. Maybe you'll find a voice or a method that somebody talks about it that you like better than me. I don't know. Probably 1 in 10, maybe more, find my voice grating and you just don't want to listen to me. I recommend watching the videos and looking at the PowerPoint anyway. One good example that kind of goes around the kind of architect world every now and then is this one here that Arc Daily put out a while ago. What I found reassuring is that came out after I had been teaching for several years, and the format is shockingly similar to what I'm teaching right now. In fact, structural engineering hasn't had that many advances for the basic premises in 50, 60 years. Earthquake has had changes, the way we do earthquake design, and materials have had changes because we're advancing and understanding our comprehension on how the materials behave. But the basic premises of structural engineering haven't changed in a really long time. In fact, I'm also doing my master's in fabric structures or lightweight structures in Germany. So every year or so I go to Bauhaus essentially and take some courses there, 2-week intensive courses. And I was sitting in the structurals component because you don't get exempt from anything. And I was sitting in the structurals component, and the videos they were showing were the exact videos I already show in my class. So it was kind of interesting to see that crossover, that around the world people are teaching these structures courses in a very similar format. So I guess the question is, why the hell are you taking this course? You're here to study architecture. What do you need to know about the engineering? You're going to hire an engineer. And that's true, but before you ever even hire an engineer, you have a big job. You have to pick the materials. Usually you already come to an engineer with the understanding of what materials you want, because you've talked it out with the owner. You guys have figured out what you want to build this out of. And that is usually very closely tied with the layout. So you've probably even done a set of drawings as a very preliminary set before you've even met with an engineer. And in that layout, you often have an idea of what the preliminary sizes are. Certainly not the final sizes, but you need an understanding of what the potential sizes are. You need to know that your ceiling height might be this big if your floor-to-floor height is that big. So you don't want people bonking their heads on things. And the reason that can matter is if you're building a 10-story building, but you have an ultimate height on the building, maybe you can only fit in 9 stories. And that's a big change to go back to the owner of the site and tell them later, oh, by the way, we didn't understand our preliminary sizes right, and we can't fit in all of the ceilings we need, so we actually have to take a story out of the building because we have that maximum building height that we're allowed to hit. You also have to understand the limits on materials. You need to know that if you're picking this material, when it doesn't work. You also need to understand that sometimes a small change can have a big impact. You make a beam longer, it does not get proportionately deeper. It gets disproportionately bigger, or a factor of 4 times bigger, proportional to the length increase. You need to understand that there are relationships between depth and length, strength and deflection. So all of those things are things we're going to learn throughout this course, but you need to know that when you're making a lot of these decisions and what could impact your final design going forward. They're difficult concepts, for sure. We're going to try to talk them through as well as we can. They have said over the past 2 years that my course is too easy. Not you guys. The administration has said the course is too easy. 2 years ago, they said that my marks were ridiculously high. So last year, I set out to make it as hard as I possibly could, and they nailed it. I had to tell the administration, I made it almost as hard as the graduate courses, and they still nailed it. And there's nothing I can do about it. And they said, okay, well, we'll take that into consideration, try it again over the next few years. So there will be a lot of math. I think it's going to be harder than I would like it to be, but I can tell you that the class tends to do really well. So the averages tend to be A- average. The people that get low marks, sometimes, rarely, it's because they find it too hard. Often it is because they didn't put the effort in. Sometimes it's a language barrier. So if it's a language barrier, you need to find yourself someone that can help you out with the language issues that you might come across. So if English isn't your first language, make sure you have a resource that can help you through that, because I want you guys to do great in the course as well. So I'm going to end the intro lecture here, because the first lecture for strength, stiffness, and stability is actually the exact same one that the graduates do. So I'm only going to record it once, and then after that, you guys will have different videos. So I'm going to stop this video here, and you can move on to the next video whenever.